Hey, welcome everybody into this month's episode of TechConnect. Guys, it is now after Christmas. I hope everybody had a wonderful Christmas season and happy holidays to everybody who doesn't celebrate Christmas. And now it is, Friday night before New Year's. I hope everybody has a safe and happy New Year's Eve celebration with friends and family. So let's get right into it. As you guys can tell, I have a whole bunch of components here that we actually spent the time to take apart because I promised you guys that we would show you what they look like inside during that last class where we were covering secondary air injection. We talked about that BMW, found the bad air pump and valve on that BMW, and then we also worked on that Trailblazer where we had this bad relay. So let's get to those in just a second. Let's start today with the question from the last class. Now the question read, Tech A says that the fuse will blow as soon as the amperage going through it is higher than its amperage rating, and Tech B said that it's common for the circuit to momentarily pull amperage higher than the fuse rating without compromising the fuse. Who is correct? Now most of you guys got this. I sent out a whole bunch of t-shirts this time, and most of you did get this right, that Tech A was incorrect and Tech B was correct. Tech A is incorrect because a fuse will commonly pull more amperage through it momentarily higher than its amperage rating. And the reason for that is because it takes time to build heat. Current plus time equals heat, and heat is what's killing our fuse. Heat is what's actually melting the element inside of our fuse. Now the quality of the fuse, along with the overcurrent limit and the way the fuse is designed will all affect the time that it takes. We could be talking 4 milliseconds, we could be talking half of a second, whatever it might be. We could be talking a pretty good amount of time for that fuse to be sitting over its amperage rating. In fact, if we look at this, this was that waveform that we saw from that BMW. I mean, here we were sitting at 105 amps when that fuse turned on. And let's look, our fuse rating was at 60. So let's call where my mouse is sitting right now about 60 amps. If I had this in Pico right now, it'd be really easy to put some cursors in here. Unfortunately, I didn't click save on this for you guys. But we're just before the 2-second mark, and I would call this, let's call this about 60 amps. We're almost at half a second above that fuse, right? Above 60 amps. So our fuse on this one is able to handle upwards of 60 amps for more than half a second. So definitely incorrect for technician A on that one. It's not the current per se that's blowing the fuse. It's not like 60.01 amps blows a 60 amp fuse. That's not the way it works. It is the heat that's created by that current that's melting our fuse. Okay? All right, now I also followed this up with an extra credit question that you guys were to answer. And that question was, why is it on the BMW circuit that they're running the relay back to ground after it's been turned off? It's kind of a funky design. We don't normally see that leg of the relay even being used. But for some reason, BMW found it to be a good idea to run that relay back to ground. And many of you did get it right. It's to counter that energy that's created after the relay is shut off. So let's look at this current graph here. Blue was current. Our current spikes up 105 amps, comes down to its happy spinning speed of about 25, 30 amps, whatever it was. And then right here at this mark was where we actually turned off that pump. So the relay shut off right here. All right, this spot right here, our relay went off, right? Now your common thought would be this would just go down to 0 and read out at 0. But the problem is this motor, this air pump, does not have a brake inside of it, okay? There's nothing to stop this pump from spinning. So when we shut off the relay and stop sending power to it, the motor actually starts creating its own power. So we're not actually doing negative current here. This is not negative 30 amps. It's just amperage flowing in the opposite direction. So instead of consuming amperage here, this thing is actually creating power on its own, okay? And the reason why they run that back to ground then is just another grounding path for that energy to go, so it's not finding its own home, okay? We're giving it a path to ground so that it can dissipate that energy. But as that pump spins and is slowing down, we are actually creating amperage. The only reason it looks like it's negative is because it's basically traveling the opposite direction through our amp clamp. Just like if you have the amp clamp on backwards. It's not negative amperage, it's just amperage flowing in the opposite direction. Okay? So that's the answer to both of our questions. Let's get to some of the comments. Let's start with Tango47. He came on and he asked, here's a stupid question. Well, first of all, I want to clarify that there's no such thing as a stupid question, guys. If somebody's out there asking it, there's probably somebody else out there also wondering. So Tango 47, you don't need to lead in with here's a stupid question, because your question's not stupid. It read, how do I know if I have forced air injection? And by forced air injection, I believe you mean secondary air injection, because forced air injection could also be thought of as like supercharging or turbocharging. If we're just talking secondary air injection here, he says he just bought a 96 Suburban with the big old 454 engine under the hood. A way to quickly check for your secondary air injection is to, one, see if you have an air pump. On a 454, that might be a belt-driven air pump. I didn't look it up, but it could be an electronic pump like our BMWs, or it could be a belt-driven air pump. But what I like to do for a real quick check, look for a hose or a pipe running to either the exhaust manifold or to the pipe between the exhaust manifold and the catalytic converter. If you have a pipe in there, that means we're flowing fresh air into those manifolds to heat up the catalytic converters. So that's what I like to look for first. It's a real quick and easy check. All right, so Nick came on and said that he would try to activate the air pump with a different scan tool. I would hate if you went for the pump and it was actually the scanner causing you issues. So Nick, I really like your point here. He was talking at this point, I believe we were trying to drive the pump on the BMW with the scan tool at this point, and it wasn't working. It showed us that it was supposedly working, but it wasn't doing what it was supposed to. Nick, you have a very good point. Sometimes our scan tools do let us down. That's the benefit of having more than one tool, is you could try it on there to see if that was the case. Now, a question for you, Nick, as a follow-up. How could you verify that the scan tool control is actually functioning? What would you do in that case to verify that the scan tool control is functioning and that the PCM is controlling the relay as intended? What would you do? What would be your next step if you only had one scan tool to verify that your control function of the scan tool is actually functioning? All right, I'll look forward to that answer, Nick, in the comment section below. And anybody else who wants to give it a shot, go for it. All right, Joe came on. He said he had another GM. The pressure sensor registered 3.3 volts with the air pump running. The O2s went lean, but it wouldn't run for more than 20 seconds from a cold start. Any ideas? Joe, my first question for this is you didn't specify if this thing actually has a problem. This could be normal. This could be the designed aspect of this vehicle. This pump on the GM might only run for 20 seconds on a cold start. It depends on the programming of the vehicle. I don't think there's any sort of rule of thumb that I can throw at you guys that says, okay, at 32 degrees, you should expect this thing to run for X amount of time. I can't say that. It's going to be different vehicle to vehicle, displacement to displacement, air pump size to air pump size. They're all going to do it differently for that amount of time. Now, I would say maybe on your GM, maybe 20 seconds is normal, or maybe you have a fault for an air pump code, and maybe you're getting a voltage drop or something in there. You know, GM, we're talking about this relay again. If it's a Trailblazer, you know, we could have an issue. Could have an issue in there. So I guess, Joe, if you want more information on your question, I'm going to need more information from you. So again, looking for that below in the comments section. All right, Kevin from EX Motorsports came on, and he said, notice how the pump is downhill from everything. That's a great point. I think these pumps should almost have a drain built in the bottom, because most of the time we do find these pumps under the vehicle or sitting in a wheel well where they are downhill from the manifold, they're downhill from the control, they're downhill from the inlet. The pump is going to be the lowest point. It's crazy, right? You put the most expensive component at the bottom where it's going to get filled up with water. I mean, I understand in proper operation you should never see water inside of this, but that's not real world. Real world, I mean, these things are failing from water all the time. I mean, this thing was so full of water. Even after the class was done, the ice was melting inside of this pump housing, and I was still draining water out of it. So I think, and somebody else had brought it up in a comment, these pumps should have like a check valve or a drain or something on them to at least allow us to get that water out of there at some point, because water is killing these things. And you'll see as we get to this in just a second that water was definitely the issue on this thing. All right, and then I apologize if I pronounce your name wrong, but I believe it's Sancte Alphonse. He says, man, this is like watching a cooking show where they magically take an already baked cake out of the oven. That is an awesome, awesome comment. You know, I love that. That puts a smile on my face, because it kind of is, right? But I want to be able to show you guys beginning to end through the repair. You know, it's like a cooking show, sure, but I told you how to make the cake. I showed you I put it in the oven. The only thing I didn't make you guys sit there and wait for is that timer to tick down from 30 minutes or whatever. I didn't make you watch the cake bake, right? I didn't make you wait for the parts guy to get here. You know, it doesn't happen instantly. And I want to be able to show you guys in one sitting, in one video, how we go from having a problem to diagnosing the problem to resolving the problem and then re-verifying at the end that everything is fixed. It's really nice because then you get to see the known bad situation, you get to get some known bad stats, some known bad data, and then you also get to capture some known good data also in the same video. So if you want to compare it to a cooking show, great, that's awesome. But yes, there is definitely some magic where magic parts appear. So thanks for the comment, and thank you everybody for the comments. There were so many comments I can't even tell you how many. I didn't even count this time. But I really love all the feedback from you guys, so I really appreciate that. Now, let's get to some pictures that I have captured here for you guys. So I have them sitting here in this folder. And before I get to the pictures, actually, what I want to do, guys, is I just want to go over these really quickly. We're going to start, let's start off with the relay for the GM. So this is the relay that was sitting underneath our Trailblazer. Right, this is the relay that was giving us a massive voltage drop. Even though we were commanding it on and it showed 12 volts to our pump, this guy was giving us issues. And I went ahead and took it apart, and it is nasty inside here. This relay got hot, and it is actually broken on the side here. We'll get to these close-ups in just a second. But what I'm really disappointed of, guys, there's no seal in here. There's no weather pack seal. There's no O-ring. There's nothing. There's nothing to protect this relay internally from water. This relay really doesn't look any different than a relay that we'd find under the dash of the vehicle. I'm disappointed in the fact that this relay does not include protection. And let's take a look at some close-up shots here. So here you can see the relay with its guts sitting in there. You can definitely see corrosion right here. You can actually see where some of the plastic is melted through here. The pin right here has plastic melted around it. And as we look inside there, you guys see there's no O-ring here, there's no weather seal, there's nothing in here whatsoever that's going to protect the guts of this relay from the elements, from water. Here you can see this right here is actually a hole. That's the table on the other side of this. This thing actually melted a hole through it. And here you can actually see that hole poked through here. So this thing melted a hole right through the side of the relay. So definitely a lot of current, definitely a lot of energy flowing through this thing. And here you can see some more melted plastic right next to where this thing was mounted to the body. There's part of that'd be the relay from the top down. You can see this looks like corrosion, water damage on there, maybe some heat, some plastic melting maybe, rust. There's the bad side of our relay. This is right about where it melted through our relay case. You can actually see that it's cracked in here. It's supposed to be connected right here, and it's no longer connected. I mean, this thing is just toast. It stinks. It smells burnt. The plastic is all melted. This thing, I can't believe this thing never blew the fuse. There's our other side of the relay again, showing more melting, showing green fuzzy corrosion here. So very, very nasty looking relay. There's a side that looks pretty good. That was the opposite side of the all that corrosion in there. So this side is actually the clicking side of the relay. So when the magnetic field activates, it will actually bring this piece inwards and energize the pin right here. So this would be the output side, I guess you would call it, of the relay. And just another look at the bottom of the relay where you can definitely see the plastic is melted there. So this relay is toast. I would think, guys, that this would be a pretty common failure point on these Trailblazers. I mean, we're sticking a relay that's passing a ton of energy underneath the vehicle. It's bound to give us some issues. Okay, let's get to the BMW components now. So here in front of me is the valve. This was the one that was mounted on the exhaust manifold. And this is the one that's controlling our flow from the air pump into the exhaust system. This is a mechanical valve with a spring inside of it. And here's, just take the cap off. There's a spring that sits in here, and there's a diaphragm that sits over that, like so. Now the spring, it's got some push to it. It's not really a super stiff spring. I wouldn't say it's, I don't know. I just wouldn't say that's a super stiff spring. Because remember, we're looking, what did we say? I believe it was between 2 and 3 psi to open up this valve. I had to pound this valve open. You guys can see in this picture here, I do have the valve open. That's exactly what I'm holding in my hand right here. You can see that I have it open here. There's the bottom side. So this would be the side that's opposite of what we just looked at. I had to beat on this thing with a hammer to get our valve to actually open. There's our spring. Oh, we'll get to that in a second. So corrosion got in here, water, moisture, created the pintle inside of here, the rod that's running in here got basically expanded out from corrosion and no longer moves free. I mean, I can't even get this thing to close again. Yeah. So even beating on a steel table, I can't get this thing to close. I would have to hit this thing with a hammer again to get it to seal up again. So she's toast. I mean, if you really are gung-ho and you found a way to open this and find a way to get it back together, you maybe would be able to clean it up. But really, guys, at that point, how much labor are you involving to clean a valve that might not last? Who knows? So we replaced this thing because it was seized up. So that's our valve there. Now let's talk about our air pump itself. Now this thing, remember, was full of water. It was pretty dramatic when we took the hose off. I think somebody even commented on there saying something about it's like a soap opera. There was some drama. When I pulled the hose off, we had like a river running out of this thing. This thing was full of water, and that's obvious by our motor that's sitting inside of here. So as this thing was taken apart, it did not come apart easy. There's videos out there with BMW air pumps where guys are actually taking them apart, cleaning them up, and putting them back together. This one wasn't that way. I don't think you'd be able to get this thing together. I had to cut the bottom side of the pump off because our motor comes out this side. So I have our motor, I have our other components of the pump, took the cover off. This, we'll call it a fan blade, actually sits inside of here with another plastic piece over the top. But this is basically just a dual unit fan. They sit something like this, and they're on the shaft of the motor, like so. And the motor spins these two fans around, creating our pressure for this thing. So that's the fans. Let's take a peek at the actual motor. Here's some close-ups of the motor. That's where our brushes are going to ride there. So pretty good sized motor inside of this thing, and we should figure that. I mean, we're pulling big amperage out of this thing. These right here, in case you guys are wondering, this motor is a quality motor. This motor was balanced when it was made. So these cut marks in here are actually balancing marks where they're taking away a little bit of the material to get this motor to balance out. And we'll look there on the other side are more balance marks. So they definitely balance this motor to keep it down for noise. The other thing I want to notice is this is not bad picture taking. These windings in here are actually black. The windings are black and they stink. They smell like burning electrical. You know, just giving it a whiff here, it smells like burnt wiring. It smells like burnt electrical. I mean, for those of us that have been doing this for a while, we've all smelled it before. This thing smells bad. So we got black windings inside of there. Inside of our motor housing, you can see our brushes down at the bottom and the magnets on the side here. You can definitely see there was water intrusion. You know, all of this rust in here definitely shows that we've had water. And it was obvious there was water inside of this pump. Water damage here, there's our rear bearing. This is our rear case bearing for our motor. And right here is the shaft. This is where our two fans would get mounted on, and there's our front bearing. And you can see just how much rust and corrosion is on here. It's pretty nasty inside. And there's some rust. You can see that there was some dust in here. And all these marks are from me trying to get this thing apart with a pry bar. It was not... It did not come apart very easy, and it will definitely not go back together. Okay, so that's back to the Ridley. So our motor, definitely toast. This front bearing, I don't think you guys will be able to hear it, but let's see. Maybe. Bearing is very noisy. There is play in our bearing. When I had this motor fully assembled still, before I took everything apart, I tried to, after I got the fan blades off, after I got the whole thing out, I tried to spin the motor over by hand, and I couldn't. It would not budge. So our bearings were definitely tight, binding up on this thing. There was rust involved. I mean, this motor was junk. Could you clean this motor up right now and reuse it? Sure. You probably could. The motor would probably still work. Throw some new brushes in there, put 2 new bearings, and it would still function electronically. It would be a functioning motor, but it's wrapping here. It's case. You can't get this back together. We had to cut it to get it apart. It's not going back together. So create yourself a nice little heavy-duty DC fan if you want. So that's about it, guys. TechConnect for 2018. It's going to be a little bit different. I'm going to talk to you guys on the, January 6th, I believe. January 4th, excuse me. January 4th is going to be our next class. I'm going to talk to you guys about a couple little changes we're going to make in 2018 to our video series and the different titles of what we have to offer for you guys and what we put out there. So I look forward to seeing everybody January 4th after the new year. We're going to do something different this time. You know what? I'm not going to tell you what's going to happen this time. You'll just have to make sure you're there January 4th. Join us at 11 o'clock Central Time for our next live broadcast. I'm going to keep it a secret until January 4th, but I think you guys will like this one. I think it'll be fun. So I think that's going to be about it. If anybody has any questions, wants to see any more with any of this stuff, put some comments below. If you want to see anything else or you have any questions. I would like some follow-up from you guys, from Nick. I believe it was Nick, right? And Joe. If you guys want your questions answered, I'd be happy to answer them. I just need more info from you guys, so let's dig through it. So put those in the comments below. Other than that, guys, I hope you have a wonderful weekend. I hope everybody has a very safe and happy New Year. Don't do anything stupid, please. I don't want to be hearing about it on Thursday in the comments section that somebody got arrested or something like that. Let's be safe. Let's be respectful. Yeah, I hope everybody has a fun and happy New Year's, and I'll see you guys all on Thursday, January 4th, for the next live broadcast. Peter's going to be joining me, so you guys will get a little bit of time with Peter as well. So until then, guys, I hope everybody, again, has a fantastic weekend, and happy wrenching, everyone. We'll see you after the first of the year. Thank you.